Assalamu alaikum, Bismillahirrahmanirrahim. Hello. So today, basically, we're doing JNCIS specialist level course, JNCIS-SP, that is Service Provider Routing and Switching. So we're now in switching part. And switching part, we're discussed today. Module is Ethernet OAM. Ethernet OAM. O means operation, administration, and maintenance. Basically, we are discussing about Ethernet OAM today. And next class will be configuration. Okay, I think it's a very little class, or you can say it's very short class. And today is theoretical part. I will cover the theoretical part of OAM, basically Ethernet OAM. OAM means operation, administration, and maintenance. There is three sections in OAM. One is OAM overview, another is LFM and OAM PDU, and last one is CFM pieces. Okay, so I show you one by one. First one, OAM overview. What is OAM? You can say operation, administration, and maintenance. It's basically related to Ethernet, basically. So OAM takes measurements as that is availability. You can say uptime, or you can say uptime is I shared the uptime, network uptime is converted to percentage. You can say 99 point something percent. So this is called the availability. How much time network is up and how much time is down. Okay. And another measurement, way measurement is frame delay. It's tracking based on layer 2. That's why they called frame delay. Okay, so frame delay time required to transmit a frame from one device to another device, taking some time. It's near about microsecond. Okay, so device is so much smart now. And other is frame delay variation. Variation frame delay measurements between consecutive test frames. That is called the frame delay variation. And last one is frame loss. Number of frame lost. It can be happen uh, due to fiber ledger, due to a loose connection, or device malfunction, like this. Okay, or link is overutilized. If your link is overutilized, so you will get frame loss. Okay, so this is the OAM measurement. In OAM, we should look over this point. Okay, so Ethernet OAM is standard. What is the standard of OAM? Operation, administration, and maintenance. So there is multiple, you can say, organization or institute. They are making this standardization. So IEEE is the one of the most you can say number one. You can say number one uh, organization or institute who are making standardization. IEEE, another one is Metro Ethernet Forum, MEF, and International Telecommunication Union Telecommunication Standardization, that is called ITU-T, have developed complementary standard for Ethernet WAN. They are combined. Okay, so IEEE, MEF, and ITU-T, they're developing the standard. Okay, so standard is like IEEE 800-3 to 2008 clauses. That is basically multiple RFs. IEEE also deliver multiple RFs regarding Ethernet frame or Ethernet. Basically, we use multiple technology in Ethernet. They use different number 800 to something like this. So link fault management, that is called LFM, link fault management. Detect faults on a single link in an Ethernet network. This LFM basically detects fault on a single link in an Ethernet network. So LFM is the portion of OAM known as the Ethernet in the first mile OAM. You can say EFM OAM. So IEEE another method like 800 to 1AG, and that is coming, and ITUT Y.1731, that is basically connectivity fault management, and that's called CFM basically. So that used to detect fault along an enter path of an Ethernet network. So you can say LFM is basically detects single link, and CFM detects the entire link, or you can say entire Ethernet network or entire path. You can just maintain ring network in your layer 2 domain. So all over the connectivity, your Ethernet network is, that is called CFM, and if you consider the single link, that is called the LFM. And MEF, that means Metro Ethernet Forum, provides the requirement that OAM mechanism must satisfy. OAM mechanism must satisfy. Provides a framework to discuss and implement those mechanisms. So this is the Ethernet OAM standard, which is coming from three different institute or organization. They are mentioning their standard. Okay. So next, OAM basics, detect network defects. Detect network defects. The primary purpose of OAM is to detect network defects or fault basically. Defect means some network function is not working as expected, or you can say fault. Okay, you can say fault or you can say error. Uh, Defect means some network function is not working as expected. And number second point is failure, defect that can disrupt or stop a network function over time. Alarm, an indication that something has failed. Something has failed. It can be you just connect your SAP, just connect with your device. It can be switch or router. Just interconnect cable between two devices. It can be, it should be up, but it's not working as we expected. That is called the defect. Okay. So second point, the use of continuity check message, that is called CCM. Basically, this use to detect the fault and sends a unidirectional message and continuously sends at regular intervals by one endpoint. If the remote end does not receive the message within a certain interval, this registers as a fault, potentially causing an alarm. Okay. So you can say in OAM, Ethernet communicating between neighbor device or peer devices and detecting those fault. Say here, so this is a node. You can say it's a router, or you can say network device. Okay, node A is connected with node B. Another is device is node C. They're connected with each other. Okay, so they're sending AIS and FDI message. AIS and FDI message. Sending this message is unidirectional, and another message is coming as a reply. Coming as a reply, BDI message. So what is uh, the meaning of AIS, FDI, and BDI? So say this alarm indication signal. This is called AIS. And forward detect defect indicator, that is FDI, forward defect indicator. That is FDI. This is for notify downstream network nodes when a failure or defect occurs. When failure or a defect occurs, they are sending this message. Backward defect indicator, that is called BDI message, notify upstream network nodes when a failure occurs in the reverse direction. So if you say this is the upstream node and this is called the downstream node. So if something wrong in downstream, they are sending AIS and API message, and for a reply, they are sending BDI message in reverse direction. So this is the indicator, and those messages are used in Ethernet. OAM basics, loopback message. Loopback message. You know the loopback is the logical interface or logical part, you can say. So sometimes we check loopback checking from one point to another point, from one node to another node. Okay. So loopback message helps narrow the scope of this issue if a problem exists on a network with multiple nodes. If you want to find any issue in individual node or multiple nodes, you can use loopback message. Assist in detecting a defect between nodes consists of two different message types. One is non-intrusive loopback message, and that is intrusive loopback message. So what is non-intrusive loopback message? Do not cause disruption to service the ping facility, like the ping facility. Just checking neighbor devices, is it okay or not? Is it dead or live? Intrusive loopback message signal a remote node to go into a special test mode. Normal transit traffic cannot flow. When they are testing intrusive loopback message, normal transit traffic will not flow through that media. So remote device slows the traffic around and sends it back out of its transit path. So see, this is a local device. It's a remote device. You can check from local device to remote device through loopback message. Another is LTM. LTM means link trace message. Link trace message. Link trace message perform a bidirectional continuity check like trace route for IP. Just sending one trace from this local node to remote node and send the reply message from send message from local node to remote node and getting reply message from remote node to local node is equal. You can say it's a trace route response. So link trace message is sending, and in replying content, they are sending link trace message also. Is bidirectional. Identify nodes along the path of the message. So this LTM message or link trace message is used to discover your enter path is okay or not okay. Okay. So we're learning here OAM some basic terms like some messages and some OAM standard. Okay, some OAM measurements. So finally, we're now in QA question answer section. What are the measurement calculated by Ethernet OAM? Frame delay and frame loss. How are CC messages sent? As unidirectional message at regular interface by one endpoint. So this is the second section, LFM and OAM PDU, protocol data unit. LFM means single link failure. To LFM use for single link failure. So link fault management, and that is LFM, is limited to a single Ethernet link. So There have some additional feature or points like remote failure indication, remote loopback, discovering and link monitoring, event notification, device pooling, fault signaling and detection, periodic packet management, processing, action profile support, operation administration and maintenance capability discovery, no alarm indication signal. All everything happened under LFM. Okay. LFM clients communication. So consider here one MX240 router and another router is also MX240. So this is the OAM PDU, sending OAM PDU and receiving the OAM PDU and also communicating LFM clients, link fault management. LFM clients communicate at the Ethernet layer to layer, not the layer 3 layer. Okay. No IP addressing necessary. No need any IP address for communication. Maximum the client sections OAM protocol data units, OAM PDU protocol data unit. OAM PDU is sent with the source address of the outgoing port and the destination address. They are never flooded. This is the destination address. Discovery process, where LFM clients discover their peers and determine each other's supported capabilities. So they are communicating in layer 2 because they are directly connected. Okay, this interface, the local interface have MAC address, also remote interface have MAC address. So they are communicating their PDU, sending and receiving the PDU. LFM clients communication. LFM clients can be either active or passive. At least one client must be in active mode, or you can say both can be in active mode. Passive clients cannot initiate discovery process or loopback control message. So one, if one is in active mode, another is in passive mode. So active mode participate in discovery process, but in passive mode doesn't participate in discovery process. So if one device is in active mode, they are sending the discovery message. Or you can say it's like Cisco CDP discovery the neighbor devices and devices others information like software, remote interface, uh, other things. OAM PDU contains some codes and flags, and this is the basically a frame format considering OAM PDU. So if you analyze one L2 frame, they have a destination MAC address, source MAC address, length or type, flags, code, data, frame check sequence. Additionally, subtype OAM. Their OAM is included in L2 frame. OAM PDU types. There are basically three types of OAM PDU. One is discovery, heartbeat, and critical events. So OAM PDU, it's discovery means they use the discovery PDU to discover the and neighbor devices basically. OAM client discover is other and exchange capabilities. For example, remote loopback, heartbeat. Second one is heartbeat. At least one OAM PDU must be sent is second. And empty information OAM PDU is sent if the client has no information to transmit. It's called the heartbeat. Critical events like link fault, dying gas, critical event. Link fault means physical layer determines that fault has occurred in the receive direction of the client. That means link is down like this. Dying gas, an unrecoverable local failure condition has occurred. It can be power shutdown or it can be um, Connected port or connected link is down like this. Critical event, an unspecified critical event has occurred. Those under in critical events. So OAM use three OAM PDU, discovery, heartbeat, and critical events. OAM PDU events notifications. This is the notification area for notification messages reacting to events like if any event is triggered, like you can say interface goes to link down state automatically, or reaction to events is locally configured. The possible action you can trigger log, or you can trigger syslog or link down message. That is, if you configure the syslog in your network, those devices sending the remote syslog server after event trigger. Okay, so this is the question and answer section. What are the conditions for a client to determine whether the client on the opposite side has LFM capabilities? So clients must go through a discovery process. Basically, when you connect um, multiple devices with each other, they are processing the discovery process automatically. No need to configure anything. Both clients must be active at the same time. It can be both active, or you can say one active, one is active mode, another can be in passive mode. So active mode, those devices sending the discovery process. What is the purpose of information OAM PDU? So and in the discovery process, signal critical events. Last one is CFM features. CFM features. Connectivity fault management. Connectivity fault management is your entire Ethernet network. Your entire Ethernet network. Fault monitoring using continuity checks. This is basically used to monitoring fault. Neighbor discovery and health check protocol. Path discovery and fault verification using link trace message like IP trace route. Fault isolation using loopback protocol like IP ping. Frame delay measurement. Maintenance domains. Say the customer bridge. It's basically a Swiss. Operator 1 bridges multiple devices in layer 2 domain. Operator 2 bridges multiple switches in a domain, and this is the customer bridge. All are switches connected with each other. Okay. So see here in level 5, customer domain. This is the customer domain. And the level 4 service provider domain. This option is the service provider domain. And this is operator 1 domain, and that is the operator 2 domain. So to segregate the label based on entire Ethernet connectivity, considering multiple service provider with customers. So end-to-end network is broken up into maintenance domains. Like its maintenance domain is assigned a label 0 to 7. This is called the label. Assignment of the label is based on hierarchy. The outermost domain must be higher than the innermost domain. Innermost domain level will be lower, and highermost domain, that is if you consider all customer and provider, that is called the level 5. This is the numeric value basically. No need to memorize all these things. A maintenance point is a port or bridge is one of three types. A maintenance association intermediate point, that is called MIP, is internal to a domain. Transparent point does not respond to CFM message. Maintenance point can be typed in one domain and another in different domain. Basically, in same thing, just segmenting customer and provider bridges and define the label. That's it. And initiate CFM message. There's three different MEP, MIP, and transparent. They are participating in this task. Like initiate CFM message, MEP is participating, MIP and transparent not participating with this initiate CFM message. Respond to loopback and link trace message, MEP and MIP participate. Track continuity check message or ping message like MEP and MIP participate, but transparent don't participate. So there are two types of MEP. Number one is down MEP. Just you can say interface is down. That is called the down MEP. And up MEP means interface that passes away from a neighboring up MEP. That means interface is up. That's called the MEP. CFM message. This is the multiple messages they are always used in CFM like CC, continuity check, loopback reply, loopback message, loopback trace reply, link trace message. Okay, all are in CFM header. In layer 2 frame, frame header format, there is one section CFM header. Under CFM header, you can mm, you will get this CFM message type like domain label, version, opcode, flags, tail info. Everything is under the CFM header. This is the continuity checks, CC message, loopback protocol, link trace message, frame delay measurement. So just by reading this one, I think no need to memorize. Just in configuration part, I will show you some tricks. And I think this last section and this the last section question and answer section. What are the functions of link trace protocol? Acts as a trace route in IP, performs path discovery and fault isolation in a network. This is link trace protocol, and this is the layer 2 frame. Arrange the components of CFM message in the correct order. So this is basically the order. Destination MAC address, source MAC address, VLAN tag, type of lane, CFM header. Okay. What are MIP used for? Exposes some of the network at a lower maintenance domain level to an upper level. So this is completely a theoretical part, and maximum Ethernet OAM concept execute device automatically. No need to configure explicitly. Okay, so when we power on the device, they are discovering neighbor devices automatically in L2 and sending some protocols, sending unidirectional message, some protocols communicate in bidirectional, but no need to configure those one. We configure and different protocol like layer 2 protocol or layer 3 protocol. But in under Ethernet OM, we are discussing LFM, we are discussing CFM. So this is happened automatically, and you can configure those one, and I will show you configuration in next session. Okay. Okay.
Yeah, okay, sir. Thank you, sir.
Okay.